Still says going live. It says I'm live. Hello out there in internet land. Okay. If you're in the chat right now, I got 6 people in the chat right now. I don't know if it's going to grow or shrink or whatever, but if you're in the chat right now, give me a hello in the live chat so I can see who you are. Oh, did I tell you? Yeah, I think I told you guys. Like I'm going to be assigning moderators at some point. Yeah, it's going to be great. You're going to have power. Anyway. I got 8 people. Oh, wow. Do your parents watch these? No, I hope not. Goodness gracious. That would be ridiculous. I got a hi. There we go. Everyone else say hi. Everyone else say hi and make me feel good. I'm on the inside. All right. I need to check the microphone while you guys are saying hello in there. So obviously, if you're saying hello, you can hear me. Fantastic. But I need to know what position the microphone works best. So I'm going to give you 3 options in the chat. I'm going to say type in a 1, 2, or 3 based on the positioning of the microphone. So this is 1 right here. You can see I'm looking in the video. It's right underneath my chin. I just need to know that's number 1. Here's number 2. Number 2 is going to be a little bit farther down. Just to need to know if I'm not yelling too loud, et cetera, if it's too close or not. And then number 3 is going to be with it on the desk right there. So in the chat, type in a 1, 2, or 3 if which position works best. This is a 1. This is a 2. And this is a 3 over here. We'll see what they say. So please type that into the chat. That'd be fantastic. Mostly 1s and 2s. Mostly 1s and 2s. Weird people. All right. Gosh. Anyway. I'm trying to figure out like an OBS studio. But so far I can't get it approved to get it installed on the computer. OBS Studio is fantastic. OBS Studio is like a streaming software where I could stitch together windows, where I could have like multiple windows going on at once. Or I could like, if I needed to like mute something, I click, boom, be back in 5 minutes kind of thing. I love that. I use it for my live streaming. Again, follow me on YouTube. If you go to this YouTube account, I think it's the only one I'm subscribed to on this YouTube account, but I digress. Okay. Now, for those of you in the classroom and those of you in the chat, at some point, I'm going to ask for your notebooks. Now, don't take them out now. Don't take them out now. But at some point, I'm going to ask for your notebooks because this is a very note-driven class, so to speak. I'll do that, and I'll go over to the Elmo, and we'll take care of all that stuff when the time comes. Usually, I'll do some kind of an intro, some kind of a discussion point, or whatever that may end up being. And then at some point, I'm going to call for the notebooks. The question always comes up, should I write this down? The answer is, if I write it down, then yes. If I write it down, absolutely yes. If I put it on a piece of paper underneath my Elmo screen, it is noteworthy, and you should write it down as well. That'd be fantastic. And we'll kind of go from there. For those of you in the chat, at some point, I'm still trying to figure out exactly how the timing is going to work. But at some point in the chat, I'm going to share something on Google Classroom, a PDF that you all are going to be able to access. And we'll kind of go from there. So excited. Oh, one last thing in the chat, because I already said this to everyone else. Summer math. I'm still working through summer math. I just got to go through that real quick. I need the time to actually sit down and do that. If you all know when I can actually have the time to do that, please let me know. Because I teach 1, 2, 3 today. I teach period 1, period 2, period 3. And then I have a hall duty the first half of 4, which means I go from 7:10 to noon with no breaks. Be jealous. Okay, whatever. What?
Just wanted to let everyone know Genesis and Parent Portal are back up and running.
Yay! I couldn't take attendance before. Okay. I talked about this a little bit the other day. This is my intro now. I talked about this a little bit the other day, and I feel like a stand-up comedian doing this. What is statistics? You're taking AP statistics, but what the heck is statistics? A lot of people think they know what statistics is making confident statements with limited information. Statistics is making confident statements with limited information. I asked this question the other day about the number of people you would have to poll in America in order to figure out, an opinion poll of the presidency, for example, or who are you going to vote for in November. There were 130 million or 140 million, somewhere in that range, people who voted in the 2016 election for president. 140 million people. Out of those 140 million people, how many do you have to poll in order to get an accurate sense of who's going to win the presidency? And in reality, you only need about 1,000. You only really need about 1,000. For the sake of argument, what's it called when you poll everybody? What is it called when you poll everybody in a certain population that you're looking for? You know the word. That's a census. Censuses, for the most part, a census is typically a dumb idea. It's typically a dumb idea. It really depends on what your population is. If I wanted to know the opinion of every single American on who's going to win the presidency in November, why would I bother spending all of that money and all of that time polling every single person in America? How long would it take me? Don't answer that. How long would it take me? How much money would it take me in order to poll every person in America? Don't answer that. But the point is, by the time I'm done, I don't know how much time it would take, but opinions would change. And then my poll is worthless. You need to be able to take it in a short amount of time. Is there about 1,000 people, students? Are there about 1,000 students in this school? Okay. You can't poll all 1,000 students and hope to get an accurate response. You're not going to get every single student's response. There's going to be a bunch of students who say, no, thank you. I don't want to take part in your poll. Or you just may not get to them. Or by the time you get all 1,000, opinions will have changed. But there are 12 of you in this classroom right now. There are 12 of you. Are you cohort 1? Cool. If I said I wanted the opinion of AP Stat cohort 1, just cohort 1, it makes sense. I would get all of your opinions. There's only 12 of you. Clearly, I can take a census then. It depends on what your population is. What is the population that you're looking at? Every 10 years, they take a census in the United States. It's federal law. And that census affects state funding from the federal level. That census affects the number of representatives that a state has in the House. And thus, it affects the number of electoral votes a state has. You got to know these things. I love it so much. Anyway, a census is typically not feasible. We'll get there. But polls are everything. Polls are everything. Samples are everything. Let me give you an example. Imagine Lake Michigan. I've never been, but just imagine Lake Michigan for a moment. Visualize in your head Lake Michigan and imagine all the fish that are swimming in Lake Michigan. And then I say to you, it's your job. I need you to figure out what is the average weight. What is the average weight of all the fish in Lake Michigan? Think about that. It seems like a ridiculous statement, but I need to know. I need to know for scientific purposes. What is the average weight of the fish in Lake Michigan? So how would you go about doing that? What's one idea? Could you catch every single fish in Lake Michigan? Bunch of people shaking their heads no. Could you drain Lake Michigan and then weigh them from there? What's a more feasible idea? What's more feasible? You can't catch all the fish in Lake Michigan. I go back to my original statement. Statistics is making confident statements with limited information. What do you do? Catch some fish. Maybe catch like 30 fish. You got to make sure they're randomized, though. We'll talk about randomization in a moment. Just catch some fish. Catch a sample of fish. It's going to be great. I want you to imagine this chair. Did I talk about soup last week? Soup in the stream? Okay, good. I'm talking about soup. Imagine that this was a giant soup bowl. I really should have brought in a giant bowl, like pot of soup. Imagine this is a giant soup bowl. And the question, oh, she's saying I did. You all lied to me. Whatever, I'm going to say it anyway. In this giant soup bowl, my job is to now figure out, okay, does this soup taste good? Good. I'm going to say it again because it's a good example. If I put this soup together, let's just say I take the potatoes and I throw them in, and I take the seasoning and I put them in, I put the broth, but I don't know what order you're supposed to make soup in, whatever. Mix it all around. I don't have to eat the whole soup. I don't have to eat the entire pot of soup in order to decide, does this soup taste good? Well, how do I know the next bite won't taste bad? How do I know the next bite won't taste different? Why won't it taste different? Why will the next bowl of soup be the same taste as the previous bowl of soup? I mixed it up. I randomized. You have to randomize. You have to randomize. Randomization is the goal of today. We need to talk about randomization and why randomization is important and why your understanding of randomization is a bit flawed. It's a bit flawed. It really is. It's really interesting, actually, to say the truth. Let me give you an example. We live in Ocean County. If I were to take a poll of people's opinion on the presidency, and I randomly picked, let's just say randomly picked, 100 people in Ocean County, does that random poll reflect that of the rest of the United States? It doesn't. If you know anything about Ocean County politics is much more leaning Republican, probably like 60-40, which is not representative of the country. If you go representative of the country, it's a bit closer to 50-50. A randomized poll has to be random. It cannot just be convenient for you to complete. If you wanted to do a randomized poll of people's athletic ability, and then you randomly picked people from the football team, oh, goodness gracious. That would be a randomized poll of the football team. It would not be a randomized poll of people's general athletic ability. Randomization is key. People think like random, like, oh, I'm random, butterfly. That's not random. Let me give you an example. I'll write this on the board, actually. Where's my marker? Here we go. Okay. I'm going to do an experiment. You ready? Pick a number from 1 to 10. I'm sorry. Let me be specific. Pick a random number from 1 to 10. Yeah. 2. Okay, hold on. Pick a random number from 1 to 10. Okay. And they can see this in the chat. Yeah, they can see this in the chat. Pick a random number from 1 to 10. Okay. Pick a random number from 1 to 10. Okay. Pick a random number from 1 to 10. Okay. Last one. Pick a random number from 1 to 10. Okay. She did not follow my directions. I'm sorry for yelling. You did not follow my directions. I'm gonna come to you one moment. Trust me. Because you hear Hannah? Shut up. All right. I hate chords. Anyway. I said pick a random number from 1 to 10. There is a Dilbert comic strip. Oh, comic strips were these things in newspapers back in the day with like little newspapers were these things where people read. Shut up. Anyway, there was this Dilbert comic in which the guy walks into a door and he's like, what department is this? It's like, oh, this is the department of generating random numbers. And there's a guy sitting in a chair saying 4, 4, 4, 4. Why did she not follow my directions? No. That's not the reason. That's not the reason. That's not the specific reason. Because that could happen. That could happen with random numbers, right? If I say pick a random number from 1 to 10, there are 10 numbers. What chance does each number have of being selected? 10% chance. But the second that you said 2, you eliminated it. You decided subconsciously that you were never going to say 2 again, unless you ran out of numbers. The second that she said 2 and then 5 and then 7, she decided in her mind that those numbers would no longer be picked. And thus you did not follow my directions because I said random number from 1 to 10. Now, could this happen? Yes, it could. Could a string of 4, 4, 4, 4, 4, 4. Could that happen? Yes, it could. That's actual randomness. Oh, I'm so excited. I like soup. Ladies and gentlemen, what I'm going to ask from you right now, this is going to be the first time you hear this. This will not be the last time you hear this. I'm going to need those notebooks out and open. Oh, I'm so excited. You two in the chat, get your notebooks out and open. You jerks. Okay, I didn't mean that. I feel like I'm doing an NPR episode. Oh, I'm stuck on your desk. There it is. Never mind. I got it. I was stuck on your desk for a second. Randomness. I love it. Okay, I'll put this coffee aside for now so we can properly stew. I'm gonna bring this back over here. I'm going to change this screen over to here. Huzzah! Let me get those numbers. There we go. Let's see here. Okay. Zoom back out. Now, typically, I'm going to try and give notes like this so that after each class, I have a physical copy of the notes just in case. But it's always good for you guys to write these things down. Now, again, I apologize for those of you in the chat. There is a glare on the screen roughly around right here-ish. But I'll try to work around that as best I can. Oh, that's what I was going to do. Right. For those of you in the chat, I'm actually bringing up the whatchamacallit. I'm going to try and actually bring up the video. Where are you? Oh, I'm in my personal channel. That's why I can't find you. I'm going to try and actually bring up the video right now so I can see the chat. Where are you, dude? I hate technology so much. Okay, I don't hate it. I enjoy it. There you are. Okay. So those of you in the chat, even though I'm not at the laptop, I can... Oh, okay. Shut up. Shut up. Shut up. Okay. Just as a note, if you're going to go into the live stream during class, make sure you're muted. But I can still see the chat. I can still see the chat, so if you comment, I can still do that. Cool. So today, this is the beginning. This is chapter 10 in the textbook, and this is called randomness. Yes, we are starting with chapter 10. There's a reason for that. We are starting with chapters 10, 11, and 12 in the AP Stat textbook. This is important. We're not really going to be doing much in terms of calculations, but we are going to be doing a lot in terms of writing and logical thinking and proper wording of conclusions and whatnot. Some of you will hate it. Some of you will love it. Whatever. Today is the 9th. I'll always give a date like that just in case as well. So let me recap some of the stuff I said today. So first of all, confident statements from limited information. I can tell you how the soup tastes just from a small sample. I could give you an estimate as to the average weight of the fish in Lake Michigan just by catching a small sample and then averaging the weight of that sample. I don't have to taste all the soup. I don't have to catch all the fish. I don't have to poll all the people, as long as my procedures are correct and as long as it is random. Now, that limited information comes from samples. My favorite thing to do as a kid was to go to the mall. When I say kid, I meant like high school, but to go to the mall and then find the stores that are giving out like free samples. Okay, everyone's like, what's a mall? I feel like you guys don't have the same life experiences that I do. Psh. Anyway. I need to drink coffee. Anyway, samples don't need to be incredibly large. I mean, they could be, but they don't need to be incredibly large. If you wanted to take a sample of like 10,000 people, you could, as long as the procedures were correct. But they don't need to be incredibly large as much as they need to be random. Random selection is the cornerstone of a lot of the stuff that we're going to be doing. Random selection is going to be one of the more important aspects of what we're going to be doing in this class. It's going to be phenomenal. Let's see. Defining randomness. There is a definition that I have in mind of randomness, but again, it's like, I knew these kids in high school. They were like, no, I'm a random person. I'm a random person. And then they'll walk in with like, I don't know. You ever see those giant Cat in the Hat hats? The tall ones? Like they're just walking to school. They're like, I'm a random person. No, you are a calculated person. You're calculating what you believe to be random and then exercising that just because you want people to believe that you're random. It's probably the least random thing you could do, Like if I wanted to be quote unquote random and wanted to freak you guys out, I would have a glass ready right here and I'd break it against the wall. But again, that wouldn't be random. That would be, I already had that calculated out prior to. But here's what randomness actually is. Randomness is knowing what the possible outcomes could be. And I emphasize the word could. Knowing what the possible outcomes could be, but not what they will be. That's what true randomness actually is. I asked for those random numbers from 1 to 10. And yes, you know what the possible outcomes could be. The possible outcomes are any whole number from 1 to 10, something along those lines, but not what they will be. So it's like, okay, I randomly pick a 7. But then if you pick the 7, and then you will subconsciously eliminate the 7 from your choices, you're violating this rule. Now it's like, well, now I know it can't be a 7 because I've already picked a 7. No. You ever do those things back in the day with like, it was like a bag of marbles and like you would like, they'd like say like, what's the probability of like picking out a red, but then you pick out like another red, like with replacement or without replacement. Like that's like kind of the concept right there. I just had flat out random number from 1 to 10, not once you pick it, eliminate it, and then pick a different random number or something like that. Very specific. I used to have a bag of marbles. I've misplaced them somewhere in this room. Nobody gets me. Somebody in the chat, help me out. I used to have a bag of marbles in this room, but I have misplaced them. I have lost them. You're AP stat kids. You don't get that? Thank you. Goodness. AP. So, types of randomness. Now, again, when I define types of randomness is knowing what the possible outcomes could be, but not what they will be. You could be talking about dice, a spinner, flipping a coin. You ever been to random.org? I'll show you random.org. Oh my gosh, here, I'll come back to the screen. Hold on. Here's random.org. Look at this junk. Random.org is typically how I would select groups. I would assign people numbers and just kind of like do it right there. Random.org is not your typical random number generator. Random.org is based on atmospheric noise, which is constantly changing. Oh, it's phenomenal. Like I could do something like, I can make a list. It could be like, okay, A, B, C, D, E, F, or some junk like that. Let me zoom this screen in so the people in the chat can see it. But I can like randomize these letters. Boom, boom, and there it is. It gives me like a random selection based on the atmospheric noise at that moment. Do it again. Do it again. It's just really messed up. Or I can do integers where like here's random numbers from 1 to 10. Give me 10 of them. Make it one column. Get the numbers. Boom. There are multiple 10s in that list because, you know, I didn't say like without repeats or some junk like that. Where's my calculator? Now, unfortunately, I can't give you guys all the graphing calculators in the world. I have to turn them into the library. But on your Chromebooks, not now, we'll get them out later. On your Chromebooks, you have a graphing calculator app. You know that? Yeah, it's really cool if you haven't already seen it. I believe there should be a button for it at some point. But let me show you something on the graphing calculator. You ready for this? You're about to be get your mind blown a little bit. Let's focus that screen. There we go. Good, it's focused. If I go to a certain app within the calculator, random int. Rand int is to give me random integers from 1 to 10. Now watch, I'm going to hit it 5 times. Hold on.
Please excuse the interruption. Will all PM vocational students please report to the auditorium at this time for a brief meeting? All PM vocational students, please report to the auditorium at this time. Thank you.
So remember that list. Don't write it down. Just remember the list. 10, 10, 2, 6, 5. Those are random integers. Yes, you could repeat. Absolutely. There is an option on some calculators where you could like do it without repeats, but this one doesn't do it. But yeah, 10, 10, 2, 6, 5. Now check this out. I'm going to do it again. I'm going to do it one more time. The random integers are what? 10, 10, 2, 6, 5? Okay, random int from 1 to 10. Okay, let's see what kind of random numbers we're going to get this time. Wait a minute. Wait a minute. Wait a minute. What's happening? Why did the calculator do that? Why did it give me the same exact list of quote unquote random numbers? It's not actually random. It's actually what they call pseudo-random. And the reason why it did that is because in between, you didn't see it, I reset my calculator. And when you reset your calculator's internal mechanism for selecting randomness goes back to its original form. And it goes back to the beginning of the set list that it has stored internally. It's pseudo-random, fake randomness. There's one great example of, hold on, I'm going to write this down. Hold on. So you do the calculator, calc random. But one great example is like put names in a hat, shake well. I'm not even kidding you. There was an AP Stat question from several years ago in which they wanted the student to describe a random selection of a certain number of things. And the student wrote out on the AP test, it was like, take all 1,000 students, write their names on separate pieces of paper, put them into a giant hat, shake well, and then select like 10 names. Perfect. Perfect. That describes a proper random selection. As long as you shake well. You can't see it in the chat, but I'm actually making this motion for shaking well. It's like you're sifting for like gold. Whatever. I love it so much. But you got to make sure that you shake well. Now, if I'm talking about the calculator being random, I just want to emphasize that this is something called pseudo randomness. It is something called pseudo randomness. There is a way to seed the calculator, but I'm going to show you how to do that another time. You can seed the calculator to start at a different position on their random number chart in the calculator, and then it would actually give you different numbers. I'll just show you an example of that right now. Just to show you an example of that right now. So I have the RAM cleared, but if I go back to rand int 1 to 10 and then hit it 5 times, it's the same exact numbers that I've always gotten. But if I clear the calculator, and then let's say I seed it to be, what is today? 9/9/2020. That's today's date. I'm going to seed it to this random function in the calculator, that rand thing. Now that it's seeded, if I go back to rand int 1 to 10, now it will give me 5 completely different random numbers. Or a unique list, I should say, or something like that. I shouldn't have said completely different. Just a unique list from the one before. Calculators and all of your fun stuff. Okay. If you have your Chromebook in your bag, please break that out now and log on and go to Google Classroom. If you don't have the Chromebook, of course, you could still access it from your phone as long as you can get signal. If you're in the chat right now, I am assuming clearly you're on a computer, you know. In Google Classroom, I am about to put a couple of items. And you're seeing me do that live right now. There we go. And these are 9/9 PDF, whatever, worksheets. I don't know what to call it. Post. Chapow. Now, my goal for today, I want to show you, number one, how to use a random number table. And I want you to be able to see it on your home computers if need be. I want to show you how to use a random number table. And then I want to use a random number table in the other worksheet that I have. We're actually going to set up a simulation. Next class, I'm hoping to set up Hi-Ho Cherry-O. You ever play Hi-Ho Cherry-O? Oh, some of you, yes, some of you know. If you haven't played Hi-Ho Cherry-O, you haven't lived. I don't know. What is that rolling in the hallway? Oh, janitor. Okay. So this is an example of a random number table. Now, random number tables are typically based on constant numbers in mathematics. If you've ever used pi at any point, you realize that pi, like what pi is like, what, 3.14159265535 or some junk like that. But pi goes on forever and is essentially a random number generator unto itself. So typically, if you're going to create a random number table, they perhaps would start at a random position in pi. Like I'm going to start at like the 1/1,000,000th digit, and then boom, random number table. And it works. It works very well. And we can utilize it to our benefit in terms of simulations. It's not always based on pi. Sometimes it's based on other numbers, but whatever. So for example, if I'm setting up a simulation, it really depends on whether or not, or not whether or not, but I'm sorry, how many digits I need to take at a time. If I say, pick a random number from 1 to 10. Okay, that seems pretty straightforward. Pick a random number from 1 to 10. 1, 1, 1, 6, 4, 3. Am I ever going to get 10? Oh, crap. If I do it that way, I'm never going to get 10. Unless what? How am I going to get 10? Ooh, it's a simple solution. It's staring you right in the face. 0. See, the thing is, if I'm going random digits from 1 to 10, here's my marker, I could say, okay, fine. Single digit, from 1 to 9, but then let 0 equal 10, or let it imply 10 or some junk like that. And then whenever I get to a 0, it implies that I'm getting a 10. And that would be the assignment of numbers. And I'm going to have to talk about the procedures of assignment of numbers in a little bit. If I wanted to, pick random numbers from 1 to 100. Okay, 1 to 100 now. 1 to 100. Okay, 1 to 100. How do I do this now? Oh, crap. If I want to pick random numbers from 1 to 100, for whatever reason it may be, how do I go about it? Because not only do I have single-digit numbers, but I have double-digit numbers, I have triple-digit numbers. What do I do? Well, to kind of expedite this situation, let's just do it like this. I would take 2 digits at a time, and I would specify 0, 1 would imply 1, 0, 2 would imply 2, 13 would imply 13, et cetera, but then double 0 would imply 100. And I would be utilizing every single double-digit number from 0, 0 all the way up to 99. But 0, 0 would represent 100. You're like, 0, 0, you're never going to get 0, 0. You're never going to get 0, 0. Where is it? You're never going to get 0, 0. Look right there. Of course you're going to get 0, 0. There's a 1% chance that you'll get 0, 0. It happens. So then it would be something like this, where I'd be like 11, 16, 43, 63, 18, 75, 6, 13. You could select random numbers like that. There are certain specifications that certain problems will ask you for, but for the most part, you could do something like that. It's just that whatever random number you're picking, you have to be consistent about the number of digits that you are taking. There may be a situation where it's like, okay, there's 12 of you in this classroom, 12 of you. Okay, there's 12 of you sitting in this classroom right now. So 12 of you, I'm pretty sure I'm going to have to take 2 digits at a time, right? Let's ignore 0, 0. I could be like, I can make you 0, 1, 0, 2, 0, 3, etc., all the way up to 12. I would ignore 0, 0. So I'd be like, okay, let 0, 1 to 12 be the students in my classroom. Ignore 13 to 99 and 0, 0. I would just have to specify that. And as long as I specified that, I'm good. So I'd be like, all right, cool. I'm picking student 11. 16 is a no-go. 43 is a no-go. 63, 18, 75. 6 is my next pick. 13 is a no-go. 76, 74, 26, 32. 7 is a go, So there you go. I just picked 3 students. It really depends on what it is that you're asking and how you're going to go about doing that. So if I have this random number table, if you guys scroll down, how many tables did I actually give you? I think I gave you 7, but I just wanted to make sure. 7? Cool. So it may be like, okay, if I wanted to do a classroom experiment, if I wanted to do a classroom simulation, which we're going to be doing a little bit more simulation next week, because this is kind of like a slow burn start. Next week, we're going to be talking a little bit about dolphin therapy. I'm so excited. But we're going to be running a random simulation with dolphin therapy. And I'm going to be like, okay, you guys are going to seed your calculators. You're going to pick a random number from 1 to 7, and that's going to be the page that you use. And then you're going to pick a random number from like 1 to whatever, and then that's the block of numbers that you use. And then theoretically, we should all be using different random numbers. Of course, there is a chance, small chance, that a couple of you would get the same exact block of numbers, but that's the risk we have to take. Oh, it's going to be great. Open up the other PDF that I sent you. Because I want to work through this one with you. First, I want to look at the other PDF, and then I want to go back to our notes for a brief time. Let's see. Here it is. Now, a lot of the time, the problems that I'm going to give you are problems from like officially designated AP Stat textbooks and whatnot, or from past AP tests, which is great. This is from a textbook. So here's the scenario. A large manufacturer of batteries knows that historically 10% of its batteries come off the production line defective, and the remaining 90% of batteries come off the production line in working condition. Are you bored yet with this type of scenario? The scenarios are pretty much going to be something like this. It's going to be like a very dry kind of scenario with numbers that you then have to take that scenario and try to figure out in a way, how do I apply what I've learned mathematically, statistically, to solve the problem? Now, in this case, this problem applies to randomly generated numbers. They want you to conduct a simulation to estimate how many batteries the company needs to pull off the production line in order to be sure of ending up with 10 working batteries. It's possible that you could select 10 batteries in a row that work. Yeah, it's possible that you may have to pick like 20 batteries to get it to work. I don't know. It's possible. I might have to go through 100 batteries. But what they want is, okay, we need to figure out approximately how many. So we need to find like an average. If you scroll down a little bit on the worksheet, you'll see that they do set up 3 trials for you. They do set up 3 trials for you. And then they ask for a conclusion. This is what I want to focus on. So, ladies and gentlemen, very briefly, before we jump back to this problem, I need you to go back to your notebooks. Let's set up a simulation. Setting up a simulation. Now, like I said, based on what we're learning today and what I introduce to you next week, we're going to be doing something with an example that I like to call dolphin therapy, where you're going to simulate whether or not swimming with dolphins actually helps with people's depression. It sounds like, what in the world? That's like the most, like, no pun intended, but the most random thing I've ever heard. Swimming with dolphins and whether or not it actually affects or helps people's depression. I know, but every single problem you're going to see in AP statistics is going to be off the wall, crazy random. Just saying. So, first of all, setting up a simulation. There needs to be an assignment of numbers. Oh, it's like my heart. Thank you for laughing. Everyone thinks I'm cold-hearted, which I am. Anyway, assignment of numbers to outcomes. So, because basically you're taking a real-life situation and you're boiling it down to nothing but numbers. I need to state a stopping point. I need to state a stopping point. I need to state when the simulation will actually stop. And I'll do that with you on the worksheet, that is. I need to identify a response variable. Just for the sake of argument, obviously you've all been through Algebra 2. And if you've been through Algebra 2, that means that you at least have some basic understanding of functions and function notation. Function notation, f of x equal to an equation. There's an input, there is an output. Inputs are typically your x's, outputs are typically your y's. Inputs are typically expressed in the domain, outputs are typically expressed in the range. The response variable is like your output. The response variable is like your y values, whatever the result of the trial actually is. We're going to get into a lot of those definitions another time. So I want to specify that repeats are allowed if working with percentages. Couldn't even say it. So, for example, if I was setting up a simulation with the students in this classroom, there are 12 students in this classroom, and I needed to pick 3 students for an experiment. If I got a repeat number, like, for example, if I pick 0, 1, and I got Kester up here, if I got him for 0, 1, and then somewhere down the line, I got 0, 1 again, oh crap, I can't do that. I need 3 different students for this. I can't pick him twice. Can't do it. But repeats are allowed if you're dealing with percentages. Because if there is a 10% chance of something being selected, like a number from 1 to 10, then clearly you can repeat unless it's stated otherwise. We'll get into those details. And then finally, you have to, not finally. Multiple trials, run, average results. Then finally, I'll move this up. Suitable conclusion. I know I got to move that up. I'll zoom in a little bit. Multiple trials are run. How many trials, Mr. Markey? I don't know. It depends. This worksheet's asking you for 3. Maybe you should run 5 or 6. It depends on the situation. Oh, I got no connection right now. Oh, crap. Did the internet go down? This is what I've been fearing. I really hope the internet didn't go down. It says connected. Hold on. We've been having trouble all morning. Retry. Okay. I don't know. Can you all hear me in the chat? Of course this is going to happen. Of course. You have like every teacher in the building streaming right now. You didn't think that this was going to be an issue? Can everyone hear me in the chat? Did you all lose me? I hope you didn't lose me. Oh, they can all hear me. I'm getting thumbs up. The people in the chat are saying they don't like you guys. I think we should all beat them up. Anyway, back to this. So I'll leave this up here for a moment, and then I'll pull this down to go back to the PDF file, but I'm going to go back to the battery example in a moment. I got to assign those numbers. I have to state a stopping point. I have to identify a response variable, which is going to be the output, the result of the trial. Repeats are allowed if you're working with percentages. Multiple trials are run. You average the results, and then you need to state a suitable conclusion. Now, I go back to the first thing that I said. Statistics is making a confident statement with limited information. The conclusion that you are making is your confident statement. The limited information that you are gathering are the trials that you run. Everything is going to boil down to that statement. Statistics is confident statements, limited information. Let's go back to this. There we go. So we're talking about batteries. What's my other marker? I had a red marker somewhere. Whatever, I'll use this one. Orange. You glad I didn't say that? Anyway, describe how you will use a random number table to conduct this simulation. I'm going to suggest that whatever I write on the board, you write down into your notes and just identify that it's coming from this PDF. Write it down into your notes and just be like, oh, these are the answers to this PDF, the Chapter 11 Quiz 1, blah, 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 blah. So it says that 10% of the batteries are defective and 90% come off in working condition. You could do 1-digit numbers here. Technically, you could do 2-digit numbers here if you wanted to. You could do 2 digits. You might get different results than another person. But if you wanted to, you could say, okay, I'm going to take 2 digits at a time. I'll do it this way. Yeah, you could do 1 digit at a time. Clearly, 1 digit would be so much easier, but I'm going to do 2 digits for fun. 2 digits at a time. Let 00 to 09 be defective. Look at that. Look at that junk that I got up there. Now we're dealing with percentages. If I go 00 to 09, that's 10%. 10% of all 2-digit numbers. Mr. Markey, you could have done 1-digit numbers. I know. I didn't want to. I wanted to do 2-digit. Then I'm going to let 10 to 99 be working. So I'm going to take 2 digits at a time. There's my assignment of numbers. There is my assignment of numbers. Okay, so I'm going to take 2 digits at a time. Trial ends when 10 working batteries are found. That's my stopping point. I need to state a stopping point. I need to identify when that trial is going to end, because if I don't, then the trial will just go on forever. I have to stop the trial once I find 10 working batteries. Okay, interesting. Let's identify a response variable. Well, what do they want me to find out? Conduct a simulation to estimate how many batteries the company needs in order to be sure of ending up with 10. All right. So the response variable is the number of batteries taken. Are they taken off the production line? Come off the production line? Pull up. Yeah. Pulled. There we go. I wanted to use proper terminology from the problem. Response variable is the number of batteries pulled to get 10 working. So like, how many batteries did I actually have to go through until I got 10 working batteries? Awesome. All right. I think we're good to go. Repeats are allowed. I'm just going to state that for the sake of argument. Repeats allowed. Again, sometimes it will be justified that repeats are allowed. Sometimes it's not. In this case, it totally is justified that repeats are allowed because we're dealing with percentages. Interesting. So they want me to run this trial 3 times. Now, I'm not going to expect you to copy down all these numbers right here. I'm not expecting you to do that. Typically, it's a lot easier when you have like the piece of paper in front of you. But again, I'm going to try and minimize the number of papers that I give you. Let me scroll up on the computer. There we go. So I scroll up on the computer. Here are my trials. I'm going to erase this junk in a minute. You'll see. But you got that all in front of you. You know, instead of Chromebooks, they should have given you guys like tablets that you could like draw on and junk like that. Whatever. It's not like I'm running the show. Anyway, so I know that I'm doing 00 to 09 being defective, and then the rest are working. So let's start the thing. I got a 10 that is working. 24 is working. 25 is working. 6 is defective. Again, I'm running this trial until I get 10 working. 92 is working. 18 is working. 97 is working. Again, repeats are allowed. 72 is working. 83 is working. At 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. How many batteries did I have to go through? 11. I had to go through 11 batteries to get that. 11 is the response variable of trial 1. 11 is the response variable of trial 1 because they wanted to know how many batteries did I have to go through in order to get that. Cool. Trial 2. Working. What was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's boring. 10. All right, trial 3. Ooh, already defective. I got it 1 working, 2 working, 3 working, 4 working, 5 working, 6 working, 7 working, 8 working, 9 working, 10 working. 11.
Will the following students please report to the cafeteria for Chromebook? Josu Canales, Maria Canales, Samantha Sapersky, Robert Wallace, Nicholas Falco, Joseph Arocho, Dana Caputo, Connor Zarankowskis, Mauricio Haro, Stephen Gonzalez, Dylan DeStefano, and Cole Cardoso. Please report to the cafeteria at this time to pick up a Chromebook. Thank you.
Cool. Now, I just ran 3 trials. I didn't get 10 all the way through. I got 11, 11, and 10 or whatever, you know. But this is what it comes down to. You could run this trial with single digits. In fact, I did run this with single digits. I did this like last week with something else. Not you guys, obviously. But I ran this trial with single digits, and I think I got like a 10, I got an 11, and I got a 13 or some junk like that. It happens. It's a random simulation. 3 trials may not be enough to make a proper conclusion in real life, but for the sake of this AP Stat problem, they want you to make a proper conclusion based on this information. So I'm going to get rid of this, and I'm going to scroll down. Oop. There we go. Come on. Okay, fine. I'm going to put it in my notes, actually. I'm going to state my conclusion in my notes to make myself feel better. Let's see. There we go. Come on, paper. There we go. Zoom back out. There we go. So here's the conclusion that I needed. Conclusion. Now, here's the thing about conclusions. The conclusion that you write in AP Statistics is going to be incredibly important. The conclusion that you write is going to have a certain level of confidence. I'm going to write out what I'm going to say, but then I'm going to say something very weird at the end of it. You're going to say, oh, which, by the way, hold on. It was 11, 10, 11? Divide that by 3. What is that? 10.67. Okay, cool. Based on the simulation, we had an average of 10.67 batteries pulled to get 10 working. Okay, interesting. Now, obviously, 10.67 batteries is not like a whole number, but, I'm stating that in my conclusion based on the simulation, blah, 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 blah. It appears the company would have to pull at least 11 batteries, because I'm rounding up to be safe, at least 11 batteries to get 10 working. This is my conclusion. This is the result of my conclusion. And in this moment, this is all that I can honestly say. When it comes to AP Statistics and the conclusions that you make, the conclusions have to be fluffy. They have to be fluffy, unfortunately. You cannot make definitive statements. You cannot say the company has to pull 10.67 batteries to get 10 working. No. You cannot say, well, we had an average of 10.67, or there is an average of 10.67, so they have to pull 11 batteries. No. Fluffy language. The fluffy language that I used here was based on the simulation. And it appears. One of the more famous examples of fluffy language that you will be using in this class, we have evidence to suggest. We have evidence to suggest. That is going to be one of the more commonly used phrases when it comes to writing conclusions. And you have to know, I need fluffy language. You are not going to be making definitive statements. You are not going to be making declarations in your conclusions. If you do, it will be marked wrong because you are not allowed to. You can run every single simulation off, or simulation and sample and poll, but you're never going to have accurate results. For example, have you ever seen a poll reported in the news where they have something called a margin of error? Yeah. A margin of error is not a mistake. A margin of error is based on what statisticians call a 95% confidence interval, in which we say, okay, the margin of error is, let's just say it's like 51% plus or minus 2%. 51% plus or minus 2%, which means that the window, the interval, goes from 49 to 53. So I'm saying with 95% confidence that the true proportion is within that interval of 49 to 53. I'm not saying that it is, because I can't. I can only say with 95% confidence. Statisticians are never 100% confident. Statisticians are never 100% confident. This is not an exact math class. This is a science class, so to speak. Unfortunately, we can't have exactitude. I don't even know if exactitude is a word. I don't care. I'm a math teacher. But we need to be able to use fluffy language. Now, just one quick conclusion for myself before we wrap up for today, and then I'm going to tell you what you're going to be doing on the computer, because I am going to put a discussion question up there for both classes, but you'll see. You need randomness. Without randomness, your statistics are garbage. Let me repeat that. Without randomness, your statistics are garbage. It doesn't matter what we're doing. It doesn't matter if we're doing a sample. It doesn't matter if we're doing experiments. It doesn't matter if we're doing probability, hypothesis testing. If you don't have proper randomness, your statistics are garbage. Just saying. It has to. Randomness is the cornerstone. You guys know what a cornerstone is? What an actual cornerstone is? Cool. The cornerstone, some of you do know what a cornerstone is, but when you build a building, they usually put like a giant slab of concrete in one of the corners of the building in order to build everything off of that. It's called a cornerstone. A lot of old buildings from the 17 and 1800s have cornerstones still there, and they're very famous, you know. Mr. Markey, this is statistics. I know. Here's something I'm going to have you think about. At the end of today, I am going to put on Google Classroom a discussion question. This discussion question is going to have specific directions for you. The directions are going to be where you give your statement, but then you come back later and you comment on other people's statements and all this other stuff. You'll see. It'll be on Google Classroom. But it's going to be based on polling. How do people properly poll? How do you get a random poll of the United States? Today, the current procedure for getting a proper random sample is generating random phone numbers. But let me ask you a question. Do you know any adult today, when their cell phone rings, that they are like, I have to answer this. I don't know who it is. Right? If you don't know who the number is, how many times out of 10 do you actually answer it? Like 0, 1, maybe? How, in this digital age, with cell phones, with people wanting to be left alone for the most part, how do you get a proper sample or a proper poll of people across the United States? That's something that I'm going to have you think about. There's going to be more directions in the Google Classroom when the time comes. Anyway, you got about a minute. I'm going to shut down the stream. So thank you guys for joining me in there. And I will be live tomorrow teaching a similar lesson. Again, you guys are not required to be on the stream. You want to come in and just hang out and just give it a thumbs up, by all means do that. I don't know. That's up to you, but you don't have to. You guys are going to be working on other stuff. Goodbye, everybody. All right.